Well, hello, Period 1 Geometry. So we're still doing this distance learning thing, still not back in school, and we are done with the unit that we started, and we're moving on to bigger and better things now, but we don't have a packet to give you. So what that means is that we're going to be taking notes kind of the old-fashioned way. So you're going to need something to write with. You're going to need some blank paper. You might want to pause the video while you go ahead and gather up those things that you need. And then once you come back, you can hit play again and we'll get going. All right, I'm kind of excited because we are going to start this new unit on trig, and trig is going to be something that's helpful to you not only this year in your study of geometry, but it'll be helpful next year. You'll see it on the SATs and the ACTs when you're getting ready to take those tests so that you can apply to college. So trig is something that's going to be helpful and useful to you now and in the future as well. We're going to start today by learning about some basic trig ratios. So I'm going to go ahead and put that up at the topic of or top of my paper. And remember, the nice thing about the video is that if I'm going too fast for you, just go ahead and pause it so that you can write your notes. You can really tailor this to be as fast or as slow as you want it to be. And in order to talk about trig ratios, I really need to talk about the right triangle because the work that we're going to do with trig ratios this year is only going to be done in right triangles. So let's talk, and we've talked about right triangles so far this year, so this is not entirely new. But remember, the way that we know that a right triangle is a right triangle is because one of the angles will be marked with that box, meaning right angle. And as far as vocabulary is concerned, remember that we call or we name the side that's opposite or across from. So I draw that little arrow pointing away from the right angle. Remember that that side of the triangle is called the hypotenuse, and the other two sides of the triangle are called the legs. Oh, I made one of them plural and I didn't mean to. So again, those two sides that come together to form the right angle are called legs. So in this picture, the two sides that I just made red are called legs, and the side opposite or across from that right angle is going to be known as the hypotenuse. That vocabulary is going to be important because we're going to go ahead and we're going to build on it now. I'm going to start with kind of that same right triangle that contains the right angle. And remember that the side across from or opposite from that right angle is called the hypotenuse. But now we're going to get a little specific with the names of our legs. I'm going to take one of the acute angles in my right triangle, and it doesn't matter which one. I'm going to call that little guy X, and he's going to be what's called my reference angle. My reference angle is going to be the angle that I'm talking about. So if I'm talking about that little green angle X, I now have to name the other two sides. Well, the leg that's across from or opposite from angle X, my reference angle, I'm going to call the side or the leg opposite. So again, it's just opposite or it's across from that angle. And the remaining leg, by process of elimination, I'm going to name as adjacent. If I were to go ahead and I were to draw my right triangle, and again, if you need to pause so that you can get these pictures on your paper, just go ahead and pause the video. The side opposite from the right angle is always the hypotenuse. But now, if I were to make this angle up at the top, I'm going to call it Y, my reference angle. Then the leg that's across from angle Y would be the opposite. And by process of elimination, this leg that's attached to angle Y would be the adjacent. So when I'm finding the names for those sides, I always do the hypotenuse first, the opposite second, and the adjacent third. That might be helpful to you because now we're going to go ahead and we're going to label some opposites and adjacents. I'm going to scroll down my paper. You're probably going to have to scroll down your paper as well. But I'm going to name this example 1. You want to write that down on your paper exactly as I did. And I'm going to start by drawing another right triangle. There's my right angle. I'm going to label my right triangle X, Y, Z. And remember that I always start by labeling the hypotenuse first. And what I want to do now is I want to name the side that is, first of all, opposite angle Z. So if I look at my picture, I kind of had the smart board so I can erase if I need to. Here's my angle Z. If I look opposite or across from angle Z, the name of the side that's opposite angle Z is side XY. So I'm going to go ahead and I'm going to erase this because I'm going to move on to a new problem now. So in number 2 now, I want to find the side that is opposite angle X. So I'm going to go to the picture. Here's angle X. The side that's opposite or across from angle X now is going to be side YZ. I'm going to erase what I labeled in the picture. So that I'll have what I need to move on to the next example. The side that's adjacent to angle X well, again, here's angle X. Here's my opposite. So my opposite was YZ. My adjacent is therefore going to be XY. And again, I'm going to give you a minute to look at that picture, and then I'm going to erase it. So that I can tackle this last question. And in this last question, I want to find the side that's adjacent to angle Z. So again, I'm going to go to my picture. I'm going to find angle Z. So there's angle Z. I'm always going to look for the opposite side first. So the opposite, or the side that's opposite angle Z, is side XY. And by process of elimination, the side that's adjacent to angle Z is going to be side YZ. And that should give us kind of the background that we need to go and learn about our 3 important trig functions that we're going to be working with over the course of this unit. It might be helpful at this point to go ahead and flip up to the top of the next page, which I think I'm going to do. So I'm going to go ahead and find a new piece of paper. If you want to keep on working, if you have room on that piece of paper, that's fine, but I'm going to go ahead and I'm going to flip up to the top of the next page. We're going to talk about our 3 trig ratios. Our 3 trig ratios are sine, cosine, and tangent. And sine, we're going to abbreviate SIN. Cosine, we're going to abbreviate COS. And tangent, we're going to abbreviate TAN. So what are these sine, cosines, and tangents? Well, sine is really just the ratio between the opposite leg and the hypotenuse. And we'll talk more about what that means here in a few minutes. Cosine is just the ratio between the adjacent leg and the hypotenuse. And tangent is the ratio between the opposite leg and the adjacent leg. And you have to memorize these. That's kind of the bad news. The good news is that there's a lot of mnemonics that you can use to memorize these. So one thing or one way that I've seen people use to memorize these is they'll take only the first letter of each one of these names. So they'll say sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent equals the opposite over the adjacent. Or they'll use the words so, ka, toa. Or the other one that I've seen is they'll use the saying, some old horse caught another horse taking oats away. Is it a little silly? Yup. Is it a little ridiculous? You betcha. But whatever it takes to help you remember, that's what we're about. So again, this some old horse caught another horse taking oats away. Or sometimes we think about this as so ka toa. However you remember, whether you've used so ka toa or some old horse caught another horse taking oats away, you have to remember that the sine is the comparison between the opposite and the hypotenuse. The cosine is the comparison between the adjacent and the hypotenuse. And the tangent is the comparison between the opposite and the adjacent. We're going to go ahead and take a look at some examples and how we would use this. And if you're a little confused right now, we'll see if we can deconfuse you or unconfuse you. So I'm going to label on my paper example 2. And you should write this down on your paper exactly the same way. You should be writing all of these notes down exactly as I have them. And on my paper for example 2, I'm going to draw a right triangle. And in my right triangle, I'm going to make angle C be the right angle. So side AB is the hypotenuse. I'm going to make side AC 5, side BC 12, and my hypotenuse, side AB, 13. I'm going to go ahead and start by labeling my hypotenuse first. And I think I'm going to abbreviate now HYP for hypotenuse. And for this triangle, I want to now find the sine of angle A. And remember that sine is the comparison between the opposite and the hypotenuse. So the sine of angle A is going to be the length of the side opposite angle A over the hypotenuse. So sine of angle A is opposite over the hypotenuse. Well, if I go to the picture, there's angle A. The side that's opposite angle A is 12, which makes the adjacent side 5. But for sine of angle A, we want to find the opposite. So the opposite is 12 over the hypotenuse, 13. So the sine of angle A is going to be 12 over 13. And I'm going to go ahead and erase so that I can use my picture to do a few more of these. What if now I wanted to find the sine of angle B? Well, sine, remember, again, is the comparison between the opposite and the hypotenuse. So now I have to go to my picture and I have to find angle B. Angle B is my reference angle. So for angle B, the opposite is 5 and the adjacent is 12. We want to compare opposite over hypotenuse. So the sine of angle B is going to be 5 over 13. And again, I'm going to take a minute and erase. What if now I wanted to find the tangent of angle A? So again, my reference angle here is angle A. I'm going to go back up here for angle A. 12 is the opposite. 5 is the adjacent. And for tangent, tangent is opposite over adjacent. So for the tangent of angle A, I'm going to have 12 over 5. So the tangent of angle A is going to be 12 over 5. If we wanted to find maybe the cosine of angle B, well, cosine of angle B is adjacent over hypotenuse. So I'm going to go into the picture and I'm going to find my reference angle B. I'm going to look across the triangle. That's the side opposite, which makes 12 my adjacent. So I want to now compare the adjacent over the hypotenuse. So the cosine of angle B would be 12 over 13. If If I wanted to find the cosine of angle A, cosine, remember, is adjacent over hypotenuse. So if I go to the picture, my reference angle now is A. So opposite is 12, adjacent is 5. We want to compare adjacent over hypotenuse. So the cosine of angle A would be 5 over 13. Notice all of these answers stay as fractions. And lastly, if we wanted to find the tangent of angle B, tangent, remember, is opposite over adjacent. So looking at the picture now, my reference angle would be angle B. Opposite angle B would be side AC. So adjacent to angle B would be side CB. And this time we want to compare opposite over adjacent. So 5 over 12. So that's how you would find all of your different trig ratios. We're going to take a look at one more example, I think. I'm going to call this one example 3. And in example 3, I'm again going to start with a right triangle. This right triangle is going to be triangle DEF, and I'm going to make the right angle angle E. I'm going to make leg ED 5 and leg EF 12. And I want to find the 6 trig ratios for this triangle. So I want to find the sine of angle D. I want to find the cosine of angle D. I want to find the tangent of angle D. I also want to find the sine of angle F, the cosine of angle F, and the tangent of angle F. And as we do this, I want you to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Some old horse caught another horse taking oats away. So sine of angle D is going to be opposite over hypotenuse. So if I look at this picture, my hypotenuse is going to be side FD, but I don't have a number for side FD. Well, remember that we're working here with a right triangle. And when we have a right triangle and we know the lengths of 2 sides but not the third, we can find the length of the third side by doing Pythagorean Theorem, by doing a squared plus b squared is equal to c squared. And remember, your c is always your hypotenuse, so I'm going to call that x. And my 2 legs can either be 12 squared plus 5 squared or 5 squared plus 12 squared. It doesn't make a difference which one you use. But I've got 12 squared plus 5 squared equals x squared, or x squared equals 12 squared plus 5 squared. So I had to get out my calculator to do this, and you probably will also. I get 144 plus 25 is equal to x squared, Or in other words, x squared is equal to 169 and x is equal to 13. So my hypotenuse here is 13. If my reference angle is angle D, then my opposite is 12 and my adjacent is 5. So sine of angle D is opposite 12 over hypotenuse 13. Cosine of angle D. Well, cosine is adjacent over hypotenuse. So cosine is going to be 5, the adjacent, over the hypotenuse, 13. And tangent of angle D, well, taking boats away, or tangent equals opposite over adjacent. So opposite is 12, adjacent is 5. So tangent of angle D is 12 over 5. I don't know why I wrote 15 in there. And now we're going to move on and we're going to use for our reference angle, angle F. So I'm going to go to my picture and do some erasing here. I don't want angle D anymore. I want angle F. So this is the angle that I want to use. So now 5 is my opposite, 12 is my adjacent, and of course the hypotenuse doesn't change. The hypotenuse is still 13. So sine of angle F, well, I find the sine by comparing the opposite and the hypotenuse. So 5 over 13. Cosine, I'm going to find by comparing the adjacent over the hypotenuse. So cosine of angle F is going to be the 12, the adjacent, over the hypotenuse, 13. And lastly, tangent of angle F, I'm going to find by putting the opposite side over the adjacent. So opposite of 5 over the adjacent of 12. All right, so I think that's good. So for some practice, Miss Andre and I are going to ask you to log on to Castle Learning. And when you log on to Castle Learning, the assignment that you want to do that goes along with this video is the assignment on trig ratios. If you haven't logged on to Castle Learning, or it's been a long time since you've logged on, your username for Castle Learning is going to be PS for Pittsford Schools, and then whatever your 6-digit student ID number is. So it's PS dash your 6-digit student ID. If you've been on Castle Learning already and you've entered your password, you'll already have your password stored in there. If you don't, your password for Castle Learning is going to be the same password that you use to log on to the school computers. So again, it's either something that you changed it to or your school computer password. If you're having a hard time getting logged on with your password, just email me or Miss Andre. Either one of us would be able to reset that password in Castle Learning for you. But that Castle Learning assignment is going down in Infinite Campus as either a complete or an incomplete. So you do want to make sure that you complete that assignment so that we can give you the appropriate credit for it in Infinite Campus. If you're running into questions as you're doing the assignment or questions with the video, please feel free to email either one of us, Or you can also attend our office hours Monday, Wednesday, Friday via uh, the Teams app. So lots of different good ways to get in touch with us if you're struggling or if you're having a hard time. All right, great job this morning, folks. Take care. Till next time, again, if you have questions, don't be afraid to reach out to us through office hours or via email.